All right, well, I am Brian Bucklew. I'm one of the co-founders of Freehold Games. My talk is largely going to be about what happens when you try to make a roguelike and you're not as smart as the two guys who have presented already. This is this is as philosophical as I'm going to get, which is maybe stories are just data with a soul. And so I am largely going to talk about the data side of that. Jason, who is the other half of Freehold Games, will talk about the soul part. So you'll get a nice soulless speech from me. So we just released Sproggiwood on the App Store 2 days ago, so my slides are a little rough. It's going well. We have previously released a game called Caves of Qud, but I have been doing roguelike development for a long time, though you've never heard of me because it took me a very long time to actually release anything. So this was an article that I wrote many years ago sitting on Usenet in a cyber cafe in like 1998 for Darren Hebden's Roguelike News, which maybe some very old people remember. But and it was about creating a map. And so I put in my very terrible code, which will horrify anybody who's smart about how to write your code, right? And the most embarrassing thing about this article is that this algorithm is still absolutely in use in Sproggiwood. I still have this code that's been ported, and the first couple dungeons are still generated by this algorithm. And so is the first dungeon in Caves of Qud. And you get to the end of the article, and I was like, oh, well, maybe I'll sign this for posterity, and I'll be important one day, right? Like so. So we got Brian Bucklew. I was 18 at the time, and I was working on a project called Dungeon, or this game needs a new name. And the name of that game was eventually Caves of Qud. And you can see that I had a very optimistic release date of early 1998, and right, and the game did not release until 2008 or so. So this is about this sort of data-driven design and the engines of Qud and Sproggiwood, because Sproggiwood is largely an evolution of the Qud design, or why did Dungeon come out in 10 years late in 3 acts? And so Act 1 is it is pitch black, and you are likely to be eaten by a grue. And so this is how I felt at the time. Right, so I'm like 18, and I've dropped out of high school, and I've dropped out of college, and I'm sort of making my way. And people, this is a very dark time in the world where you don't have the internet to go and figure things out. And so you've maybe gone to a college library and gone through the card catalogs and find books about how you do raycasting or make programs work. And so you get a lot of people at the time that are saying, hey, object-oriented design is great. Why don't you make a class hierarchy, and this is how you should do it, right? So, you've got vehicles, and from those you derive wheeled vehicles, and you're like, okay, well, I think that this isn't too hard, right? I'm going to start with a weapon, and it's going to hit things, and I'm going to get an elemental weapon that deals damage, and the second one should not say elemental weapon, it should say ice sword. This was a tragedy of the Sproggiwood release. But you go, oh, great. I'm a genius, right? So now I can go in and I can go weapon deal damage to whatever it is, and one of them's dealing fire damage, one of them's dealing ice damage, and it's wonderful, right? And you build your game, and you got a little guy walking around and dealing ice damage and fire damage, and you go one day, hey, what if I want a fire ice sword? And suddenly things don't look so good, right? And this would happen more than once, or you would collapse the data to say, okay, well, let's get rid of this. Maybe I'm not so smart anymore, and we're just going to make an elemental weapon with some flags that are fire and ice, and that works. And let's keep going. And so eventually, surely, this time I have it. And so at this point, it's like 2000, 2002. I have built a roguelike to the point where I can play it, and then I try to add some stuff to it, and it just doesn't work, and I feel really bad about myself. And I'll go like, oh, an openable wall, that creates one of these horrifying diamonds, and a creature chest, which is a mimic, that doesn't work either, and now I've got to collapse those. And oh, a weapon armor, that doesn't work either. And this is how I felt for the first 4 or 5 years of trying to write a roguelike that I just didn't hate working on. And so a few papers were coming out at this time. And I was still a very young engineer that didn't know what I was doing. But I thought that these papers were interesting, and some were particularly good. And I've got a bibliography at the end for anybody who wants to go out and read them. But there were a couple really influential ones about the systems a guy named Scott Billis wrote about Dungeon Siege, right? He talked about how he built not only component-based designs, but these really cool like C++ scripting tools. And at the end of these, he said something that sort of caught my imagination, which was, hey, I wrote this in C++, but had I had .NET at the time, I would have probably used reflection. And I had no idea what reflection was at the time. Like, I was like, what's reflection? But Scott Billis says it's cool, so that's interesting. And so I sat down, I had this stuff in my mind, but I didn't know how it applied to roguelikes. And one day I said, well, this is just not working, these class designs. What's wrong? And I started to do what later in my life I would realize was requirements analysis, right? So the IEEE says it's a condition or capability needed by a user to solve a problem or achieve an objective. IE requirements, what problem really am I trying to solve? Because I think it's an important question to ask yourself, because it's very easy to solve the wrong problem because it's fun, or to solve the wrong problem because you don't realize that somebody has come to you with a solution, right? Very often when you do real world engineering, people will come to you with a solution. It's very important to ask, well, before we implement the solution, what is the problem actually that we're trying to solve? And so I do not intend to say that I did this mindfully. I accidentally asked myself these questions one weekend in a fit of frustration, but it turned out to be the right thing that I eventually canonized into part of the process. And I said, well, what really am I trying to build here? I wanted to build not a good piece of code, which you'll see later, right? And nothing I'm doing here is a good piece of code. What I wanted to build was a big emergent sandbox of a world. I had been playing games like Rogue on my 8086 and games like Omega and Alpha Man, right? These games which I thought were awesome, but I would look at them and go like, man, you could take this one step farther, right? You could have really isometric feeling objects where I could go in with games would start to do this. I could pick up a tree and hit anything with a tree, right? But those were very hard-coded sort of instances, and the thing that I felt was really interesting were these credible feeling isomorphic worlds, right? And I wanted to be able to think of some new interaction, right? And add it to the code without the code increasing in complexity exponentially. I wanted to be able to say, hey, I have an idea, and I want to implement it, and I want it to have a linear relationship with the complexity of the code. So that maybe the first thing that I write, a fire sword, is a little more difficult. So maybe it takes 5 units of effort. But the 4,000th thing I add to this code, because in the kind of roguelike that I'm making, not these very elegant little things with these big sprawling games, I wanted to make sure that the 4,000th thing I added took also 5 units of effort, right? And that meant largely that I was trying to remove the code as a barrier to game inspiration. I wanted to just get it out of the way. So it's something that's there, it has to work well enough to play the game. But I figured out that the most important thing to me was to get that code out of the way of just thinking up of an idea and putting it in the game. And that largely meant decoupling, technically, right? When you start to collapse class hierarchies, you start to couple these ideas so that if you've got a big old list of is fire damage, is ice damage, am I invulnerable, right? Each one of those, even if only a tiny bit, starts to couple to the next thing you add. And so the next thing you add gets a little more complicated and a little more complicated. So even if all you're doing is adding a new elemental type, you have to remember all of the places that know about that damage type, and eventually you get to the point where the code just collapses, like I showed it in before. And so I started thinking about the ideas that were floating around at the time in terms of component-based architecture. And so this says that instead of a hierarchy of things, everything in the roguelike could be just an empty object. So an object with nothing in it does nothing, right? Well, that's a nice little bit of parsimony. That's probably good behavior, right? And so you can inject into the object a list of individual components that know about their own thing. So a composite object that has a physics behavior and has a render behavior and has maybe a weapon behavior that makes it a little more specialized than an object with just a physics and render behavior. I said, well, this is a pretty good idea. And I didn't think about this so much as just tried it, because my coding technique is not to very carefully think about things, but just try everything that doesn't work, right? And so I started saying, well, how are these things going to talk to one another, right? So if I've got this object and I've got these components, it wasn't really well specified in some of these discussions how these components were supposed to interact. Nowadays, this is actually a pretty common pattern, and there are some really good papers on it, but I was sort of just like, again, in 2002, internet is not very well developed. You're on like somebody's GeoCities page or Usenet going like, I like component architecture, right? And getting pictures of their children or whatever. And so in my professional work, I was doing Win32 programming. So if anybody's written Windows programming, the way they talk are events. And I was like, events seem like a pretty good thing to do here because it allows Windows to talk to one another, controls to talk to one another without deep coupling, right? I can send an event that says draw to anything in a Windows system, and it can take a very domain-specific behavior. And so I started building the system. And this was still in C++ at this time. I was building something, I was like, oh, Fubi is so cool. If you go read Scott Billis's Fubi, that it would bind automatically to DLLs. And so I got this partially working in C++. And this is around 2003 or 2004. And I said, well, here's how it's going to work. An event will come into an object, and it will just go through these components in order. And these objects can, during this processing, just fire events to other game objects. So it won't talk to components. They eventually did, just for optimization. But conceptually, all they do is these events talk to other components. So a physics behavior, a render behavior, a weapon behavior doesn't know anything about the other kinds of behaviors. All they can do is fire these isomorphic events that all these components can see. And so I started building some practical solutions. One of the first things you want to do is you want to make a little kobold run around and kill it with your sword, right? And so I said, well, probably everything in my world is destructible because that's a fun world. So physics has 10 hit points. And physics will understand a take damage event and subtract the amount in there by 10. Now, there's a little bit of coupling here that the things know about take damage. But I'm actually just using string events. There's not even, in Caves of Qud today, like a big table of actual event IDs or anything. It's literally just a string that switches inside the component on the string. And so suddenly you've got this take damage. You could have a second object that wants to have a very specialized damage, like say, I'm a mouse and I have very specialized body parts that can be damaged. It could respond to take damage in a very different way by just having a different instance of the physics component. But I hadn't gotten that far yet. I was just like, is this going to work or is this going to collapse like a horrible class hierarchy problems I've had for the last 6 years of my life? I said, well, one of the things you want to do is be invulnerable. So how would you do that in a component-based system? Well, let's create an invulnerability component. It will be the first thing in the handler list, and if it sees it takes damage, it will assign the amount to 0. Then physics will get that event, which has been modified by the invulnerability, and it takes no damage. Well, that's cool. And not only that, but the physics doesn't know anything about invulnerability. Physics has not changed. All physics knows about is hit points. What about elemental types? Well, let's add a new type equals fire, and these are just name value pairs, so there's no definition. I've just added literally type and fire in here, and now I can add a fire shield component that says, hey, if the type is equal to fire, set the amount to 0. And physics still doesn't know anything about invulnerability. It doesn't know anything about elemental damage types. It doesn't know anything about shielding, right? I have injected elemental damage types here with no coupling. And I said, this is working pretty well. So what if you wanted to pick up any object in the world and hit something with it? Which is something you often want to do, right? In real worlds as well as virtual ones. And so I said, okay, well, what's going to happen is the physics behavior will get an event from whatever's running the system. Let's ignore that from it, right? It's physics on that side too, but physics says, okay, well, you've been hit. You're hitting something. You've been a melee attack hit. Your target is X. You do whatever you want. If you want to do nothing, that's fine. It's your feather. And so the base implementation is maybe take damage and amount relative to the weight, which might be a property on physics, and the type is bludgeoning. And so, well, now I can pick up anything in the world and hit you with it, but what if a sword does something different? Well, and so here's the code, right? So this is the actual code for, so we create a new event. I send this event to myself that I'm dealing melee damage. I can modify the amount of damage. This lets me then plug in a weapon behavior. So the melee attack hit comes in, the physics behavior says, hey, if there's any components here that want to specialize damage, I'm going to fire a dealing damage melee event. You listen for it, and you can modify the event. And I'll do that before I send out the take damage. So physics sends a dealing melee damage event. A weapon behavior now has a type and a damage. It modifies it, and out to the target object goes take damage 1 to 6. Again, physics doesn't know anything about being a weapon, right? All it's done is added a new kind of event that you can hook into. And now I can go crazy, right? I can go, oh, weapon behavior is slashing. What about that fiery type that collapses? You know, fiery type, okay, that's cool. Fiery will come after. It says, oh, well, I'm a fire sword. I'm going to add fire to the type of damage I'm dealing and add another 1d6 to the damage parameter before it goes out. And here's the fiery ice sword behavior, right? So now here's the implementation of a completely non-connected fire ice sword that completely collapsed the previous hierarchy, but is now divided into 4 components: a physics behavior, which is orchestrating this behavior, right? A weapon behavior, which is dealing some base damage, and a fiery and ice behavior, which are adding elemental damage, and it's completely decoupled. And this really worked. I kept adding stuff to this until I had Caves of Qud, essentially. So that was many years. And so I realized at some point in the C++ implementation that the biggest problem with this system is now, what is a kind of object? If I wanted to make a new kind of object in a class hierarchy, I would derive it, and now I can create instances of it, right? A kobold is a kind of monster. I can create a new kobold. But here all I have is a bag of components that have names, and an object is just a list of these objects. So a frostburn sword is a physics behavior plus a weapons behavior plus a fire behavior plus an icy behavior. And here's data, right? I said I need some way to define a blueprint. Like, what is a frostburn sword? A game object can have any combination of components, and each component can have its own parameters that change the way it behaves. So that you may have an armor component, and a little armor, you've got leather armor, and it has an AC of 3. You may have plate armor with an AC of 6. And that's just a variable on the armor component itself. So I need a way to define these. And this is when the light bulb goes off in my head. And this is like 8 years of working on this, right? Like, oh, this is what Scott was talking about when he said reflection. I see now, right? Because the blueprints look like this when you start to put it in data. Here's a physical object. It has a physics part and a render part. Give it some defaults. A sword inherits physical object. And what that means is this just saves me typing. When this inherits a physical object, all it says is I'm going to take all the component definitions and pretend they're at the top of this list. And a fire sword is the same, a sword that adds a new component, fiery. Well, this is working pretty well. How are we going to make this string together? And so this is the whole engine of Caves of Qud and Sproggiwood. You end up, for efficiency reasons, doing things like letting components talk to one another directly, not just via events, because practically you're rendering things at a certain frame rate, right? But conceptually, this is all that's going on here. You have events. Each event has ID and a bag of parameters, name value pairs. You've got a component definition. Its only interface is fire event. It takes an event class that you've defined. You've got a game object, which is just an ordered list of components, and fire event. And that's how you get an event to an individual component. You're not ever using the component fire event. You are calling it on game object, and it fires it on each of its internal components in order. And then to create these, you have some factory, which loads these blueprints and allows you to pass in a blueprint name and return you a game object. And that is the whole thing. And so I started to put this stuff together in the game. And so let's see how it works in practice. So here is the actual C# code. This is the reflection that Scott Billis was talking about. So if you haven't worked in a language like C# and Java, at the time it was all new. Nowadays, this is what all the kids do, right? Everything's duck-typed, dynamic stuff. But this was cool when I got into it, right? So I go through all the blueprints. And so for each part blueprint, so that's each component list. My nomenclature is a little different in the actual code. I look in a namespace xrl.world.parts with the name of that blueprint. So I look for a class called xrl.parts.weapon. And if that's defined, I dynamically create an instance of it. I go through each field of it, and if it has a public member named damage, I have a big piece of code that says, okay, well, if damage is an int, I'm going to try to convert it to an int, or if it's a string, I'm going to just paste in this damage if it's a string. But it allows me to dynamically create these parts. So to create a new component, all I have to do is create a new class as public members, And that's it. I can now create it with my factory. So here are some practical examples of some of the first things we did in Caves of Qud. So I've got a water container, and the important part is up there at the top. So you've got a liquid volume. So this is a component that knows how to make this object contain fluid of all kinds. And Caves of Qud has like just this ridiculously over-elaborate fluid simulation system. And so you've got a canteen. So canteen says it's a canteen. It changes its description to an aluminum jug, and it inherits from water containers, so it gets all these default properties. And so in code, one of the things it does, so here's the actual implementation of fire event. So all the real programmers will be horrified because this is how my code works, right? So fire event takes an event. It says, hey, is the ID get display name? And down at the end, it just appends get liquid description to the end. And so at the bottom, you can see the result of this. So the default implementation of get display name starts with just the name of the object. So in this case, it's water skin. And then it sticks the liquid description at the end, which is empty or 32 drams of fresh water. Cool. I was like, this is working pretty good. Then we said, well, one of the first cool items we added to Caves of Qud was a recycling suit, which was like a dune still suit, right? So you're walking around, and in Qud, water is your currency, and you're collecting water in this still suit. And I said, well, that means this armor is really a water container, right? And so what it is, I literally just inherited from armor up there, and I added the liquid volume about halfway through, and at the bottom you can see the result. You've got a suit of armor that has 8 drams of fresh water in it, and you can click it, and it gives you the menu to empty it out or fill it up. And then you can see at the bottom I've got a little new component called recycling suit filler, which does and again, liquid component knows nothing about being filled up, right? This recycling suit filler watches for the begin turn event, and every so many turns it says, oh, do I have a liquid component? If so, add, fire and add water event. And that is it. So some interesting notes are that Caves of Qud now has 1,400 individual components. So if you could imagine trying to build a class hierarchy with your brain, right? I can barely build one with 12 instances. And so if I was trying to sit down there and map out what a class hierarchy with 1,400 little individual boxes looks like, I would just never be able to succeed. And so the component architecture scaled really well for me. The other interesting note is that when I picked up Unity 3D, I realized that its engine looked almost identical to this, right? And I didn't copy this, I just developed it at the same time in the same kind of environment, using the same kind of sources, and so you got parallel evolution of 2 very similar component systems. And so what I'm describing here is not unique to Caves of Qud anymore, right? I certainly do not propose that I invented it, but I invented it at the same time from the same sources, and it's an architecture that works really well in a lot of production games. And so if you're not a smart person like me, right, if you're dumb like me, this system works really well to allow your small brain to chunk it up and write functionality without having to overheat thinking too hard. And so that is it. Thank you. Any questions? Yeah? So the question is, how do I edit those 1,400 components? And the answer is, yes, it's Notepad, and Jason hates that. Right? So Jason does a lot of the design. I'm like, hey, look, I wrote the system. I put in 200 example objects, have fun. And he's like, these aren't even in alphabetical order. And right, they're just the order that I decided to implement them in. And so you can actually, Unity is a really nice front end to exactly this kind of system. They've built a GUI front end. There's plenty of commercial game engines that have when you look at the data, so we can drop back to the data here. Right, this data is really well structured. It is not rocket science to build a GUI editor for this kind of thing because it's literally name value pairs and a list of string tied to a list of strings, right? So if you feel like engineering something, you could definitely do that. I'm just super lazy, and so I'm like, you've got Notepad and it's fine. Oh, well, yeah, Jeff said that yeah, duh. Right, the small talk programmers of the world, and plenty of programmers of the world, this is obvious stuff that's been around for 100 years, right? And this is not new stuff. I'm just trying to expose it to the people who've gone to CS 101 and had a college professor that doesn't know what they're talking about and tried to tell you to make a class hierarchy, and it's not working. It's because it's not a good idea. Yeah. And so I wanted to, if you're building a roguelike and failing, people tend to take on roguelikes as a first programming project for some reason, and it's one of the absolute hardest things you can possibly do. So if you're trying this and failing, it is okay, because it is seriously hard. And if you're thinking like, wow, I never really asked myself what problem I was trying to solve and came up with an answer, that's okay too, because that's the key challenge of engineering. And the best engineers I know still are improving day to day at learning to ask themselves, am I solving the right problem, right? Learning to ask yourselves, am I solving the right problem in the right way, is something you're going to improve on your whole career and never really be particularly good at, because your simian brain is just not well equipped to deal with those kind of problems, right? At best, you're hacking it to be able to come up with any kind of solution to those problems at all. Okay, so the question is, in my talk, I showed the events coming in a priority order, right? So that one component could capture an event and respond to it before a second component got it. And the answer is, in Caves of Qud, in this code that you're seeing, it didn't, right? That was a problem I realized earlier. And so I solved that in Caves of Qud by having really inefficient chains of events. Begin attack, right? Attacking, after attack, really after attack is done, right? And so you forced a hierarchical order like that. In newer revisions of this engine and in Unity, the typical solution is in your part to have a priority which has some default, like 100. And if you assign a higher priority, you just keep those components in a priority queue instead of a list. And when you insert a part, you just insert it in the priority order. And that allows you to control the event flow. Sproggiwood still doesn't. I haven't found it really to be that useful, because a chain of events just works and it's really controllable, and I don't have to worry about getting the priority right. For other projects that might not be appropriate, it's not too hard to add, right? Because the only difference is in that architecture slide, instead of a list, it's a priority queue, and you're assigning that priority somewhere. Any other questions? No? Okay. Well, I'm done.